All right. All right. Good evening, everyone. Thanks for joining tonight. My name is Taylor Magnus with High Country Conservation Center. I'm the Energy Programs Manager here. We are a local nonprofit based in Frisco, and our programs help Summit County residents save energy, water, combat climate change, and divert waste by effectively recycling and composting. So if you want to check out our programs, any of those other programs that we offer, go ahead and go to highcountryconservation.org, check that out. Tonight, we're going to be talking about, sort of right in the title here, but top 3 energy efficiency opportunities for upgrades in the Wellington neighborhood. And we're going to connect you with some resources and contractors to get those projects done. Before we fully dive into all that information, I do want to just go over a couple key things I've kind of mentioned a couple times already, but about the webinar controls for you. So if you have any questions, just kind of general questions, or have any issues with audio or visual, anything like that, go ahead and drop those into the chat. I think it's that speech bubble down at the bottom of your screen. We'll have some of my colleagues, Narelle and Jess, kind of watching that chat, answering any of those technical questions. And then we do have all of you on the call, the attendees muted tonight, but we do definitely want to encourage you to ask questions about the material that may come up through the process. So we've got a Q&A section enabled. Go ahead and just drop your questions in there at any point during the presentation as you think of them. My colleague Narelle will be monitoring that. And then at the end, we're going to have a good chunk of time with our panelists. We've got a couple panelists on the call today, professional contractors that do the work around here in Summit. So plenty of time at the end to ask questions of them and myself, and we'll go through those at the end. Last thing, we are recording this webinar, so it'll be sent out after the presentation here to anyone that signed up for the session, as well as we're going to send it to the Wellington HOA. Hopefully they get that sent out to anyone that might not have been able to sign up or make it tonight. So send some other follow-up with that, some resources to help get some of this stuff done. And with that, I'm going to dive in. Okay, top 3 efficiency opportunities for Wellington homes. This presentation today is really all about making connections, things that we've seen before and are really excited about the opportunities and resources that we can share to make some of this stuff happen. I do want to start off with a little bit about what makes the Wellington community so unique. I think it truly is a very local community population in this county, in Breckenridge, and it's really a neighborhood set up for local families and friends to live side by side and live, work, and play, which you all do for the most part right in the community here all day, every day, all year. So very local community that we want to support. Most of these homes were built around the same time in 2007, 2008. They were pretty similar construction because of that, and they're for the most part all deed restricted, which comes with certain opportunities, challenges that we definitely recognize as well. And then in true Summit County fashion, most of you live very active outdoor lifestyles. So totally understand the dilemma between, do we make an upgrade on the house or maybe get a new mountain bike or skis? Definitely appreciate that struggle. So I think that's where one of our primary programs can help, which is the Energy Smart Colorado program. It's a statewide program that we implement here in Summit County. And through that, we are able to harness funding from local towns and governments to fund low-cost energy assessments FYI, those are $99 after rebates, and great educational tool for your home, as well as sort of follow up with um, very substantial rebates that we offer for energy saving projects. Um, so here on the slide, you can kind of see what that process looks like from start to finish. You can go online, sign up, and fill out that enrollment form. Once we get that, that's our cue to reach out and get you signed up for a home energy assessment and get that scheduled with an expert building analyst. I am one of those. I do want to take a moment here to just kind of break down what that assessment looks like a little bit more because it is quite comprehensive and in depth. So I'll break that down here more. Um, the building analyst will come out once you get that scheduled with them, spend a few hours at the house going through quite a bit of information, collecting measurements. And we look at everything pretty comprehensively in the house, how the house is using energy, what factors contribute to that. We look at things like insulation levels, lighting, appliances, how all of that is working together to affect the bills that you're seeing at the end of the month. One of the main tests that we run, you can kind of see here in that image in the center, is called a blower door test. And what that does is test the air tightness of the home. So we set up a fan and seal it all in the doorway and then depressurize the house and look for anywhere where there's air gaps that normally our heated air might be escaping. It's really important because that typically is one of the biggest inefficiencies we see in homes in Summit County, is that warm air escaping or cold air able to get in through those gaps in the building envelope. And then on the right side of the screen there, you can see an infrared image with sort of its non-infrared counterpart there. And that's a tool that we use as the blower door is running to walk around and see how energy is moving in the house. So the sort of yellow, orange coloring in there is the warm spots, blue, purple coloring is the cold. And that just helps give us a really good idea of, like I said, how energy is moving in the house. If there are air gaps, those really light up on there with kind of starburst blue patterns of cold air coming in. So that's a really important tool for us to use. And then we, during the assessment, we're looking at energy, absolutely. But we are also, like I said, looking at comprehensively how the house is performing as a whole, health and safety checks with the building components, the HVAC equipment or heating and ventilation of the house. So we're making sure everything's running smoothly and operational and safely. And then we're also looking at things like occupant comfort. Obviously, that's a huge deal up here in our mountain climate. Want to make sure everyone's cozy and safe and comfortable inside. We also do have the opportunity at the assessment to do several direct installs, is what they're called. Basically, just some measures that we can do right there on site during the assessment, put them in and start saving energy right away. So things like door weather stripping, smart thermostats we can install, and we can also help get you hooked up with some all LED lighting, high efficiency lighting, if you don't already have that. We take all that information that we collect during the assessment, put it into a customized comprehensive report that we send you. And that's kind of the final result of that process. Back to our overall process here. Once you get the assessment done, get that report, it's a lot of information. I know. So that's why we're here to help advise you on next steps, help you come up with a game plan. There are a lot of sort of prioritized recommendations that come out of that assessment and are in that report. So we help kind of walk you through that with any projects you may be thinking about. And then once we can also connect you with contractors to help get those projects done. Like I said, we've got Seth and Elizabeth on the call here. They both are on our list, do energy saving projects in the county here. So other contracts in the area we can connect you with, get those projects done. And then many of those will qualify for our Energy Smart rebates, which can cover a big chunk or even all of the cost of those projects. They go up to $4,000. We'll talk a little more about those and some other resources later, but can be a huge help in just getting these things done and not breaking the bank in the process. So actually for a second, like I mentioned at the start of this and really why we're here is we have done a few or several of these assessments now, specifically in the Wellington neighborhood, and even some projects there too. And we're starting to see some common themes because they are pretty similar construction, and we're starting to see some of these similar opportunities in all these houses. So I do really just want to point out what those things are that I'm seeing that are kind of the top ones that match up to our rebates. We've got contractors for. That's really that connection we're trying to make here. So to start off with that, the crawl space is number one. This is the area underneath your floor. It's in just about every Wellington house that I've seen, at least. Has one of these right underneath the building. It's typically the footprint of the whole house, so it's pretty big space. And for the most part, what I've seen is these are all completely uninsulated right now. So you can see in that top right image, there's basically no insulation under the floor. Many of them are pretty poorly sealed. Maybe they've got a vapor barrier down on the ground, but a lot of times it's maybe it's in kind of rough shape. Maybe vented in some cases as well, straight to the outside, which means there's a lot of cold air coming right through that space, right beneath your feet, and basically making that space the same temperature, similar temperature as the ambient air outside. So pretty cold, and you can imagine that is the source of quite a bit of heat loss. Oh, and we also in Wellington, we are heating off of boilers that are running hydronic heating, which means they have hot water pipes that are, for the most part, located in these crawl spaces. So that's a big opportunity. And even to the point where at least the majority of the houses that I've been into, they actually have a heater down there on one of the main heating loops. You can imagine when that thing heats up, that's a lot of heat going into a space that's not conditioned, not insulated, contributing to quite a bit of heat loss. That heat loss also contributes to high utility bills at the end of the month. And indoor comfort can be an issue. One resident in Wellington that I talked with, did an assessment for, said that she had trouble even getting her lower level heat up to past 58 or 60 degrees, which obviously is quite chilly. So that's a big factor as well. And then the state of these also kind of opens the door for some other potential issues in these spaces. If there's any water damage or water leaks down there, start seeing some organic growth, maybe some mold or fungus even growing down there. Not stuff we want to be breathing in with those spaces pretty connected to the rest of the house. We've also got some radon down there that we want to make sure is mitigated properly. And then just overall kind of durability of the building. So couple issues in this space and definitely a big one to tackle. And I'd say the solution for this is just to fully encapsulate that space, crawl space encapsulation. It's a big project. Elizabeth is going to elaborate on what exactly that looks like and what that entails a little bit later. But basically, it's sealing the whole space up, insulating the exterior walls, and getting everything kind of sealed together so that it's included in the building envelope. And it's just a much safer, more energy efficient space for the building. All right, so that's that. Oh, I did add some pictures in here from my experience. So these are pictures I took from assessments that I have completed in Wellington houses. So the top left there, you can see is a crawl space hatch coming up on the infrared there. You can see some connection around the edges. It's not sealed, not insulated. Definitely a connection point with the rest of the house and that cold space below. The infrared image and its counterpart to the right there, again, we're seeing a little bit of connection maybe through that baseboard. And then we've got really what this image is showing is the temperature difference between the floor itself down below and the other heated surfaces or walls in the room. It's about a 10-degree temperature difference, which might not sound like a whole lot, but when you magnify that across the whole first floor of the house, it certainly accounts for quite a bit of heat loss there. And then that bottom left picture, that's an interesting one. So that is from a heating unit that's down in the crawl space. It's basically pointed right at the heating pipe coming into it, or the hot water pipe coming into it. You can see that's at about 130 degrees, and the surrounding space is at maybe 36, 35. So it's almost a 100-degree difference, and you can just imagine how much heat loss that means for that space. And then right in the middle there, we've got maybe a little bit of past or current water leak that is creating a little bit of a uh, some kind of organic growth there, maybe some fungus or something that we don't want absolutely to be breathing in the rest of the house. So mitigate that, seal the space will help prevent those issues from coming up. All right, moving along. The next big opportunity that we've identified is in the attic. This is up in the top portion of the house. Kind of think of this as the hat on top of the house. And the attic is one of the most crucial building components of any house because it's where all of our heat wants to move. And it's really the barrier that's stopping that from just escaping the house, keeping that heat in where we want it to keep us comfortable, keep everything working well. And it also has a big impact on the overall performance of the house and the roof system that's protecting it from all those um, environmental conditions. And what I typically see in Wellington homes is that they have about half the recommended insulation value up there. If anyone knows too much about insulation, you've heard about R values, which is what insulation is measured in. And for our mountain Summit County climate, R60 is what's recommended. I typically see about R30, at least what it's rated for in the attic spaces up there. And even with that, it's probably not performing at that level because of air leaks into that space through the ceiling or walls. Um, Maybe it's pushed around or was never really installed perfectly. So there's little gaps in there. Um, and the attic hatch is another spot that I see that's just completely uninsulated, usually has air leaks coming through it. And it's not a huge space, but can really impact that overall performance. So all of this leads to, again, heat loss, high energy bills, can also impact indoor comfort because if you're having trouble keeping that heat in at those high points, um, your heating system is going to have a really hard time keeping up with the overall heating load of the house. So may be struggling to keep up the temperatures with that. And attic air sealing insulation is one of the single most effective projects uh, because it is a single area of the house that you can do quite a bit of work in and get some really good results in all at once. Again, Elizabeth is going to talk more about exactly what that looks like in a few moments, but it's a great thing to get done if you haven't done it already. Again, got a few pictures from my experience and my assessments here. There's that attic hatch again, kind of similar to the crawl space hatch, but you can see that's just lights up on the infrared camera as a big cold patch and some air leaks around the edges of it. The image in the middle here, we've got a bathroom exhaust vent that's poking up. This is from the attic side looking down at that. And you can see daylight through the edge of it. So that means there's quite a bit of an air pathway there for heat to escape. And probably an older bath fan anyways that may be allowing some heat to escape, kind of acting like a little chimney in there. So it's a good project to get done if you're doing some work up there anyways to replace those. And on the right side here, we've got an interior wall on the infrared camera there. And what happens with this is we've got framing going up the wall and then what's called a top plate at the top of the wall. It's basically just a piece of wood going across the top and all that framing meets in the attic. And there's just not a good seal there. It's a lot of wood connections and it allows heat to pretty easily work its way up the wall and out of through the attic space that's cold because it's vented. So you can see that coming up on the infrared camera here. Cold air coming in, which normally would be our hot air escaping under normal conditions. All right, and then big opportunity number 3 is going to be the water heater in these houses. Most of the mechanical equipment in Wellington homes is still the original from when those were built in 2007 and 2008. The boilers, you can see on the right there, that's that green box is your main heating system. Those may have some life in them still. Not the most efficient, but they still, uh, 16, 18 years will still be running. Seth can talk a little more about what he can help with on those. But the water heaters is that big tank next to it. Those are certainly past their end of life, I would say. Serviceable life, anyways, at 16 or 18 years. And they're starting to show it. Some of them that I've seen, you can see that image on the bottom right there. Maybe a water leak that's causing a little bit of corrosion on that unit that may cause some issues down the road. We don't want. But the other thing with these is that they are standalone natural gas water heaters. And they're naturally venting, which means they are combustion appliance. They're combusting natural gas to produce heat to heat up that water in the tank, and then using pressure differential between hot and cold to basically just naturally vent the exhaust fumes from that process out of the flue pipe. But you can see it's an open vent there and basically the top of the water heater. And if there was ever a malfunction or a blockage, something that went wrong with that venting system, there is a serious risk of carbon monoxide getting into the house, which is a serious health concern to anyone in the home. A lot of times these are pretty close to where we're living and eating and doing our normal activities. So definitely something we want to be aware of. And aside from all that, they're older units that are about 62% efficient. So think of that as you spend $1 on heating water, you're only getting about 62 cents worth of heating out of it. And there's just much better options out there at this point. So again, not the most efficient units. There is that health risk for occupants in the building. And then, maybe starting to see some wear and tear on those just being older. So about time to replace those. And what we recommend is going to an all-electric heat pump water heater. Now, all-electric units can be a little more expensive if it's just the traditional kind, but these heat pump units are both safer and more cost-effective than those gas units. So it's really a win-win. And Seth is going to talk much more in depth about those, drop some serious heat pump water heater knowledge on us. So stay tuned for that. Okay, last thing I really want to touch on for my portion, I know I'm getting pretty much to the end of my time here, is our local rebates and resources that we can hook you up with. I think that number right in the middle kind of says it all, but we have rebates up to $4,000. They can cover 100% of project costs. Drop the mic. No. So all of these projects I've just mentioned can qualify for up to that full $4,000 in themselves or separately. So attic project, air sealing insulation can qualify for up to 4,000 and so on. So they do have to meet those rebate requirements, which our contractors we work with do know those. They can walk you through that or have that conversation with you, make sure everything meets those. But it's going to be a good upgrade, and most of those are going to be right around that range probably. So most or all of that project covered, which is huge. That said, I would probably be recommending these projects regardless of that because they're so, I personally think they're really valuable improvements to be making to these houses, do have a pretty good payoff, but if you can get them covered, it seems like a pretty big no-brainer to me. And then the last thing that is really part of this connection we're trying to make here is many of these houses are deed restricted and have that appreciation cap, which automatically qualifies those households for a larger amount of our rebates. So again, just trying to make that connection. You guys in that Wellington neighborhood could probably qualify for these projects. We're making these connections with the contractors. Let's get this stuff done. And a few other resources we just want to mention. Excel Energy has some great rebates for all of the projects that we've mentioned here as well. There are some federal tax credits available that you can capitalize on as well from the IRS. And there's even some bigger federal rebates potentially coming soon. No hard date on that quite yet, but we're hoping for next year. So keep an eye on that. And then we, as HC3, are here to help you through all of this. So I know it's a lot of information, a lot of moving parts. If you want to get the assessment or have already gotten the assessment and just want help taking those next steps, give us a call. We can help walk you through that. And then last piece for me here, I just want to point out here is the list of contractors that we have available that we have personally talked with and sort of vetted for quality and that they can work with you on those rebates. Obviously, we've got Elizabeth here to talk to you today about attic and crawl spaces, and Seth Powell is going to talk to us about water heaters. But we do have some others, and we'll be sending out the full list there if there are any other projects you're thinking about that we may have rebates for or can help connect you with some folks for. Got the full list. We'll send you at the end of this, along with the rebate list and the recording for this webinar. All right, I'm a little sick of hearing myself talk. So with that, I am going to pass it off to Elizabeth McBurney, expert in air sealing and insulation and a whole host of other things. And with that, Elizabeth, you can unmute yourself and take it away.
Thank you, Taylor, and thank you for having me, and thank you all for joining. My name is Elizabeth McBurney. I run McBurney Built, and I'm a general contractor, and but I have a big belief in all the things that Taylor has mentioned. I'm a big believer in improving the energy efficiency of our homes. I'm a passive house builder, which entails building homes that are extremely airtight, so you can lower the capacity, or you can lower the size of the mechanicals that you use and have a more efficient home that can perform at a much higher rate and uh, run much more smoothly, have better indoor air quality, and cost less to operate. But within this purview of energy efficiency in the homes and the programs that are available, I have 2 crews I work with, and we've been doing this work for about 5 years in the county, maybe 6, and we've had a lot of success in making homes perform better. Um, we work hand in hand with HC3 as well as Excel and doing the work that's prescribed in the assessments. And as Taylor mentioned, the assessments are a great tool not only to understand how your home performs and its inadequacies, but a good pathway moving forward to make it more efficient and also more comfortable and a little less expensive to operate. So we can get into how our homes perform and the stack effect, which I'm going to keep it real simple in describing how this works. It's essentially, we all know how warm air rises in a house. What we don't all understand is how that can affect how your home performs and how it feels. So, with differences in pressure from the inside of your house and the outside of your house, it can cause air to either come in from the outside or move from the inside to the out. And neither is ideal in when you're spending a lot of money to keep it warm during the winter. So by making a home a little tighter and the building envelope we want to keep as tight as we can, and when you imagine what the building envelope, it's essentially in this picture on the upper right, you can see the red outline, and that's how we refer to our building envelope. And that's essentially the conditioned space in a home. And in our climate, especially during the winter, and the pressure changes either in the winter and in the summer, but especially in the winter, it causes that warm air from low to rise up and out and take away all that money that we've spent trying to keep it warm. So the work that we do on these homes prevents the depth of the stack effect, ideally. So we're making it to where there's less air movement and more climate control, and then also better air quality. So we can keep some of the air from the outside out and then allow some of our air from the inside to get out on its own as well, because we don't want to tighten these houses too much, because then we would need to add mechanical ventilation, which is a good thing, but it can be expensive. And so with the way your homes are built, we don't need to do that, but we can tighten it some to make it perform better. And one of the it's all fairly low hanging fruit that you'll learn through the assessments that are performed on your home. But the two crucial areas are the crawl space and the attic. And so, as far as doing a crawl space, we would go in and essentially turn the crawl space into a part of your home. So currently, you're essentially heating and cool, or just heating the space where you live by conditioning that crawl space and encapsulating it. We are making it more efficient. You'll have less cool air coming in. And by closing off those areas that are vented, it prevents that stack effect from building up quite as much as it does. This these photos are a project we did at Farmers Corner. I didn't have any good photos of Wellington neighborhood, but we ended up removing the insulation from the floor system, which seems a little anathema to what you might think is a good approach. But according to building science principles, I think it's the best approach. So we've replaced that poorly performing vapor barrier that you can see in the upper left picture, the black plastic, with a thicker 12 mil vapor barrier that we then tie into the walls, the foundation walls of the crawl space that currently aren't insulated at all. And you can see the white, it's kind of a padded look, and that's an R19 blanket insulation that we run along the walls of the crawl space, connected with tape to the vapor barrier on the ground. And then the portion where the framing of the home meets the top of the foundation is called a rim joist. And we use a closed cell foam, spray foam on that. And the closed cell foam offers good R value. It's probably the best that you can get, but it also goes the farthest in air sealing. And you'll hear us say air sealing a lot, because I think it's one of the best approaches you can make to improving the performance of your home. So by doing this, we've essentially created another space of your home that is preventing the exterior air from getting in. So you've got a warmer crawl space that then leads to a warmer space above it, and less airflow from this crawl space up through the house via the stack effect, and then out through the roof and or the attic. And so you've created um, a home that's easier to heat. So you've got less cold air, and so it's you're not having to heat as much, and therefore you're saving money, and you have a more comfortable space to be in. So, and then we'll move up. Oh yeah, there's a couple other options. This house is in your neighborhood also, and it was extremely leaky, and the vapor barrier was poor, and we've been able to add a strong vapor barrier. And this vapor barrier on the ground, if some of you use that space for storage, it's thick enough that you can, and it's, oh, I can't think of the word right now. It's, oh, I can't think of the word right now, but you can walk on it. And so you can store things on it. So you're not running the risk of ripping it. So it's a real thick, heavy plastic. So we've just had great results. And even while the guys are down there working, we've had customers notice that their floors are warmer and that their house is a little more comfortable. So the crawl space is a great approach. Now we move up into the attic, And I think in the attic, if even if we didn't add any insulation, which you don't have to, but I think is a very good approach because we have such a extreme climate here. But we go in and we push all the existing insulation out of the way so we can get in and air seal every penetration, every section location where wood meets wood, any place where there's any sort of air leakage. If that's the only thing you did and you did a really good job, you would already improve the performance of your home. But a lot of insulation companies will come in and just add extra insulation, which in the long run might improve the R value slightly, but not enough to make it worthwhile. That time spent air sealing is huge. And you can see around this pipe at the base of it, we use can spray foam, and we have can spray foam that we have these real long nozzles on them so we can get back into the eaves and to some of the really tough to reach places just to control the airflow in that attic. So, but combining the air sealing and the insulation can really increase the R value. We can get it up to closer to where condensation can't form and to where you have a much more comfortable house. And one of the other benefits of adding insulation like that and air sealing is not only are you warmer in the winter, but also you'll be cooler in the summer. So it's kind of a double bonus. But what we like to do is do the air sealing, and then we come in and blow in either um, cellulose or fiberglass, and we'll build a dam around that attic hatch and then air seal the hatch. We rebuild those typically and add weather stripping. So, such as in that photo with the thermal camera that Taylor showed earlier, we reduce the amount of cool air that can transfer. So it makes for a much better performing attic and improves the quality of your house. So the process, once you have your energy assessment complete and in your hands, then you can look through the list of contractors. And I will say, any of the contractors you reach out to on the list will do a great job for you. The benefit of working with us is that we can do the the whole shebang. We do the insulating and the air sealing. We don't do the mechanical work. That's where Seth Powell would come in. But so what I like to do is have you email me your report. We can talk it over a little bit. I do like to schedule a site visit, even though your homes are all very similar and we really know the problem areas, we can target them easily. I like to meet people in person because I want to make that personal connection with you, make sure you have make sure I have your trust. I can answer any questions for you in person. And then from there, I can go provide you a quote. And then if that works for you, then we'll get the work started. And then following the completion of the work, we perform a blower door test at the end ourselves. As Taylor mentioned, he's a building analyst. I'm trained and certified as a building analyst as well. So we perform our blower door tests so we can prove that we've met the criteria that will allow you to get the rebates. Once that's finished and we've proved that we've met those parameters, then I submit all the paperwork and the results and photos through to HC3 via Energy Smart as well as Excel, and then the rebate process starts from there, and then the payments, if everything works out as it should, the payments go directly to you. So it's a fairly seamless process. There's a lot of smart people who are extremely efficient working at HC3 and in the Excel realm. So this process goes smoothly. And throughout the process, we're all happy to answer any questions you might have and help you get a house that will feel better in the winter and potentially in the summer, and ideally cost a little less and have less of an impact on our environment in the end.
Great. Thank you, Elizabeth. That was awesome info about attics and crawl spaces. Hopefully we'll get some of those done in the neighborhood there. I want to introduce Seth Powell. Seth is with Pro Systems Mechanical is his company, based out of Fairplay, but does a ton of work in Summit County. And I've gotten to know Seth really well, and he's a great guy that really knows his stuff. So Seth, take it away.
Thanks, Taylor. I'm going to kind of go over heat pump water heaters and what they can do for you. I just on Tuesday and Wednesday, I went down to Denver to the Heat Pump Summit, and they had a lot of good information. It was a pretty cool event. So, water heating is the second largest energy expense in U.S. homes. So it accounts for 14 to 18% of your utility bills. And the average home in the US spends $400 to $600 on water heating every year. It could be a little more in Summit just due to the low groundwater temperatures that you have coming into your systems. So these heat pump water heaters can be a source of a lot of savings for your home. You can move to the next one. Heat pump water heaters are really, they're only about 1% of the market currently. But in the next 5 years or so, I think you're going to see a big upkick in just hearing about them and people using them. So, water heating is the second highest use of energy in the average building. Heat pump water heaters are by far the most efficient water heating option available right now. The cost of the heat pump water heater will more than pay for itself over time. You can make money back on these pretty quickly. They're environmentally friendly. They generate no greenhouse gas or carbon emissions. There is a big movement towards net zero homes in the US. 2030 is the target on that. And you see a lot of cities, bigger cities in the US that are really moving towards these goals. And as Taylor mentioned, the Inflation Reduction Act, which is still kind of a gray area as far as how they're going to do that, but that could be a huge source of getting some of your money back on some of these projects in the future. And then there are the local rebates as well that you can get on these projects. So a heat pump water heater sometimes can be called a hybrid water heater or a hybrid electric water heater. They look pretty similar to a water heater. You'll see some pictures of them. They have the heat pump is on the top, so that looks a little bit different. You don't need an HVAC license to install them because the refrigerant part is totally sealed on these units. There is a such thing as a split heat pump water heater, which has two components. There's a tank inside and then a condensing unit outside, which typically uses CO2 as a refrigerant, which operates really well at lower ambient temps. Those are an option, but they cost quite a bit more than the all-in-one units that you put inside. There are 4 modes generally on these units. You can have a heat pump only mode, which maximizes your energy savings. They have a hybrid mode, which saves, but it will get you a little bit faster recovery on your hot water because these do have electric elements in them as well as like a standard electric water heater. So you can also do electric only, which would just be like a standard electric water heater. And then most of them have a vacation mode, which you can turn on if you're not going to be around, which saves money while you're gone, lowers the temp of your water. Properly sizing the tank is pretty important on these units, especially when replacing a gas water heater because they're just not going to have the same recovery rate as the gas unit. Doesn't have quite the same horsepower as having a big old blowtorch going underneath your water tank. So you just normally you go up a size on the heat pump water heater, and that's enough for most homes. And if I can come to your house and talk to you about how many people you have and what kind of fixtures you have and about your hot water use to make sure that we get the right size tank for your home. And all the manufacturers have sizing tools on their websites as well, which can be pretty helpful in that. If you're not familiar, with what a heat pump is, it's basically just a refrigerator. I've heard a lot of people talk about the reliability of heat pump water heaters, and that's kind of a common myth that people think they're going to break down. And I guess ask yourself, if you have a 20-year-old refrigerator, how many times that's broken. They're pretty reliable. So it's basically just a refrigerator running in reverse, and it's heating instead of cooling. So you have cold air coming out and heat going in. Whereas if you stand in front of your refrigerator, you usually notice on the floor that it's warm in front of the refrigerator because it's pumping heat out of the refrigerator. So it's the same concept as that. And here's just a little diagram of that refrigeration cycle. You're evaporating the refrigerant and losing heat, and then it goes under compression, and then in the condensation part of the refrigeration cycle, you're getting the heat out and into the tank of the water heater. And that's why it's so efficient, is it's not creating heat, it's just moving it. So that's where you get all your energy savings from on these type of systems. Here's a little picture one with the covers removed. The heat pump's on the top, so it draws in ambient air using a fan. And the evaporator absorbs the heat, and the compressor increases the temperature and pressure of these all use R134A refrigerant, which is common in the automotive sector. So that in that box there, moving the heat only takes a very low amount of wattage, where a standard electric water heater is about 4,500 watts of power. So that's a huge savings. And then the condenser coils kind of wrap around the tank, and that's how the water absorbs the heat from those. And you can crank the temp up to these up to 140. That requires the use of a mixing valve, which is part of the plumbing on top, so that you don't have a scald hazard in your home. But that can kind of stretch out your hot water availability, because you're mixing in a little bit of cold water with the hot water that comes out of the tank. And then at the bottom there, you've got your tank and the electric elements that are in there as kind of a backup. You can use those under high demand or in hybrid mode. So something else I just wanted to mention, for most of those homes that have the gas electric water or the gas water heaters, you're going to need to do an electric upgrade to get a 20 or 30 amp circuit into that room, depending on the unit you go with. They do offer 120 models, 120 volt models of these that plug into a standard outlet. The issue with those is they can have a pretty slow recovery, so that can save you some money, but you just have to make sure that you're not using a lot of hot water. And that's something that we can talk about if you decide to have me take a look at these for you. Just another slide about seeing the light with the heat pump water heaters. So in heat pump mode, you're talking about 5.5 incandescent 100-watt light bulbs. I know there's not a lot of those around anymore. I don't think you can buy those anymore, but if you can imagine a standard electric water heater, you get up in the morning and take a shower, and that's like flicking on 45 100-watt incandescent bulbs. So that's quite a bit of power that you can save right there. So no carbon emissions, and they pay for themselves. So your payback is return on your total investment of the product, including installation. So Taylor mentioned earlier that the gas water heaters are about a 0.6 to maybe 0.62 UEF, which is a uniform energy factor, which is a fancy way of just saying their efficiency level. So with a heat pump, you can easily get up into the 3 point something figures where it's producing more than 3 times the amount of energy that you're putting into it, which is, I mean, it's really just amazing that we're just doing this now, because heat pumps are pretty amazing. So I think on the next slide, it talks about, yeah, so you've got some energy guides here from heat pump water heaters. So your standard electric, which is 0.93% efficient on a 50-gallon electric, and then your typical heat pump water heater at 50 gallons, it's $419 a year to run the electric and $115 a year to run the heat pump water heater. And then the next two there are just going up in sizing on a heat pump water heater, which increases the cost a little bit with the 65 and the 80 gallon there, but still considerably less than the standard electric. And then on the bottom there, your standard gas tank at 63.63% efficiency. It's about 300 a year versus the 115, and then a gas tankless right around 170 versus the 115 a year for the heat pump. So all around, they're the best method for heating as far as reducing energy use. Best locations for these in your homes there, with your water heater being in your mechanical room with your boiler. That's a great place to put these because if your heat's running, it's always warm in that room. They do really well in that type of environment. They tend to decrease the ambient temp in the room that they're in 2 to 3 degrees when the heat pump's running. So it's really not a lot. It's hard to notice. But there's, other places that you can put them. These things will work depending on the manufacturer. They can work down to 40 degrees or just under 40 degrees, and they can still pull heat out of the air. But the setup that you guys have there in the Wellington is pretty ideal for installing one of these. What's the same as a standard electric water heater? So they have a pretty standard, or gas too, the sizes that's available. And then the first hour delivery is going to be pretty on par with an electric water heater. But the gas, that's why you have to upsize, because it doesn't have quite the power to heat the water as the gas one. So that's why you want to go up a little bit on the tank, just so you have a little bit more storage to get you through your high use times. They have the same sizing as a standard electric water heater, or any water heater, so they'll fit right where your water heater is now. You can duct them if you don't have proper airflow, but I think in this particular instance that we're talking about, there's combustion air inlets in those boiler rooms, so you're going to have plenty of air circulation, warm air coming off that hydronic piping in there. But this just mentions that you're supposed to have 700 cubic feet of space in the room, or a louvered door with 240 square inches of free air space on the louvered door. You need a little bit of room for servicing them, around the tops, but as long as you're not sticking it right up against the wall, that's not really too much of an issue. They do have a condensate drain because of the heat pump, so it's not as much of an issue around here just because the air is so dry. But they can move up to 2 quarts of moisture out of the air per day. I don't know this for sure. I don't think Taylor and I talked about this, but standard boiler rooms have a drain. I'm guessing there's a drain in those rooms, but I don't know that for sure. And there is an air filter on the heat pump where it draws the air, and those do need periodic cleaning. Most of these new units though are smart, and you can get the app and it will tell you when it needs to be cleaned, or just set yourself a reminder and periodically clean that air filter that's in the heat pump unit. Now, some common myths about heat pump water heaters is that they don't make enough hot water, and they do have the same performance as a standard electric and hybrid mode if you go with a 240-volt model. Challenging to install. Most of them are going to top connections, so that's pretty easy. Doesn't work in cold climates. Like I mentioned, you can get them down to under 40 degrees ambient and they still work. They do have a little bit of fan noise, but this one says 55 decibels, but they've gotten down to around 45, most of them. So it's like a quiet dishwasher. They'll work in garages. You guys don't really have to worry about your condensate freezing because of where you'd be locating them. You don't need a refrigeration technician, and that they cost too much. And with the great rebates available, they probably end up going to be less than a standard replacement. So they're a real great option. If you'd like to take a look at one, don't hesitate to get a hold of me, and I can take a look at your home. And we work on boilers, and hydronics are kind of our specialty, and we do all mechanical work. So if you have anything you'd like us to take a look at, don't hesitate to reach out.
All right. Thank you, Seth. That was some awesome info about heat pump water heaters. Well, we've run up against our time here, but since we started a few minutes late, we'll leave a few minutes at the end here for some Q&A if anyone's got some burning questions. Jess or Narelle, did you guys see any questions coming in?
Yes, hello. So we have the first one from Doug is, please explain that the improvements qualify for appreciation cap. Does that mean if I've added all possible improvements, fence, garage, this can be added to the cap?
Taylor, I can answer this one.
Thank you, Jess. That was
Yeah, so what Taylor was saying earlier is that these energy efficiency improvements, if you have the appreciation cap on your deed restriction, that automatically qualifies you to receive HC3's rebates up to $4,000. They are usually income based, but for homeowners that have an appreciation cap, we use that as an automatic qualifier. So the rebates that Taylor was talking about earlier, you are eligible to receive the full amount up to $4,000 if you live in a deed restricted home with a income or a cap on appreciation. Now, whether or not you can fold them into your resale value is a question that you'll have to ask Town of Breck Housing directly. I'm gonna share the rebate info and requirements right now in the chat. So you can check that out to see what the rebates are, what equipment qualifies.
Great, thank you, Jess. So our next question is, I have radon mitigation already. What is the impact of properly conditioning my crawl space?
Elizabeth, do you want to take that one?
Sure. So we commonly work with radon mitigation companies. And I mean, as far as the impact, I mean, it can only improve. We would work their vapor barrier, depending on how well it's done. We may want to add our vapor barrier as well, but we make sure that all of their perforated pipe is underneath and that the radon mitigation system is not affected at all by anything that we would do.
Hopefully
I
that
don't know if that
answers.
properly answers your question, but There's no negative impact on it.
We can
It's
also let Doug talk if he would like to kind of follow up on that question. Doug, I'm gonna hit allow to talk. You'll have to unmute yourself, but if just let us know if that has answered your question.
and I just to add one more thing to that, I think part of what Elizabeth is saying here is it's absolutely a consideration that's taken into an account for these projects. And sort of the same goes for the attic with what she was talking about earlier in her slides was the ventilation up there is a crucial piece of that whole space working well and is something that she has the expertise and her team has the expertise to make sure that all works well so that the building's performing as it needs to and safely as well.
Doug, do you have any follow-up questions to that before we get to your last question? Awesome. So Doug's last question is the Inflation Reduction Act. Please elaborate.
Yeah, I can definitely speak to that one. So the Inflation Reduction Act was a piece of legislation passed by federal government in 2023. It went into effect right at the start of the year. And it offers some pretty major incentives for all things energy efficiency, as well as a number of other things with new construction, but we won't go into all that. But the main pieces that are relevant here are the tax credits that became available immediately in 2023 for energy efficiency upgrades. It also extended the tax credit available for renewable energy. So if anyone's interested in solar on the roof, which have been done in a few Wellington houses, check out our Solarized Summit program for that. Morel might be able to drop a link there, but there's just a few days left, so get that done in the next week if you're interested. So those are the two big tax credit areas, and then maybe I'll just say some of the things that are available with that tax credits are available for are things like insulation materials, air sealing materials, high efficiency heating equipment. Heat pumps are a big one. They've got a $2,000 tax credit for heat pumps and heat pump water heaters. Seth and I were just talking about this. I can't remember which one it fell into, but I think it's a pretty good tax credit for those as well. And then the other thing that legislation did was basically provide the framework for bigger rebates for a lot of the same stuff. Now, those rebates from the federal government have not been totally deployed yet, but we have heard most recently that they're shooting for the end of this year with the state of Colorado. So the Colorado Energy Office is a really great resource if you want to stay up to date on those bigger federal incentives from the IRA. Maybe Narelle, if you want to drop a quick link to the Colorado Energy Office, that'd be a good thing to have in there. So that's the sort of lowdown on the IRA. If you have any other questions, we can absolutely, give us a call. We can help kind of walk you through that. I will say we're not tax professionals, so it may be some stuff to talk through with your accountant if you have one, or just check out the IRS. They've got some good resources too.
One other thing I would like to add with Taylor is there is a link in the chat for Rewiring America, which is a calculator that you can put information about yourself and your home into to see what is already available and what's anticipated to come for those tax credits and other incentives. All right, our next question is from Michelle, and it says, can you install radon mitigation when you seal your crawl space, or would that have to be done separately?
Good question.
Want me
I'll
to?
let Elizabeth take that one too.
Okay. We are not certified radon. We are not a certified radon company. So when we do projects like we're currently doing one this week, where the customer is adding radon. I work directly with Colorado Radon Solutions, and they come in, install their piping, and then we install, and then they also let me know where they're going to be putting the outlet to then run the radon system to get that air, that radon out of the crawl space. And so we work hand in hand essentially to make sure that some of the work we do doesn't interfere with the work they do. So ideally we're doing it at the same time. And there's a couple other radon specialists that I would suggest as well, but we like to work at the same time just to make it simpler. Oftentimes the radon guys will come in, install their pipe, and then we'll do our crawl space. And then you can have the radon system installed whenever you're ready. It doesn't have to happen right away. But we as a company do not do it ourselves.
Great, thanks, Elizabeth. Our next question is probably for Seth. It's from Doug saying, my water heater is in a utility room that opens to the outside. Could I install a heat pump water heater? As the space can't have louvered doors and is less than 700 square feet.
Doug, it's highly likely that it would probably work there for you. It's 700 cubic feet, so 10 by 10, which might be a little bit bigger than what that room is, but with the boiler being in there, and I'm guessing you have some combustion air inlets. They have done some testing where they didn't really get negative effects until they took it down to like under 400 cubic feet. So something we can definitely look at. I think it's possible.
Awesome. Our next question is, can these credits apply if I do the work myself? And this is from Doug. So Taylor, this is a good one for you.
Yeah, I'll take that. So, Doug, we do have some sort of policies around DIY work where I would say there's certain things that we can rebate for DIY work, but certain things that we can't. And some of that comes down to the just the possible risk of kind of doing more harm than good. And some of the stuff that Elizabeth was talking about, she's a trained BPI professional, so trained in the um, uh, building analyst and certifications and how that all how these things affect the overall performance of the home. So there's just some stuff, especially with the air sealing and insulation, you want to be really careful with. And we typically recommend that you get a certified contractor to do those those projects. That said, I will say we have rebated some projects where folks were able to put in a new appliance themselves. Maybe they had a little bit of an engineering background and were able to show a lot of documentation that showed that it was done with quality and safely. So I would say at the very least, we might ask for some additional documentation in that case, but I would recommend, especially with the rebates, just hiring somebody that really knows what they're doing to do most of these things that we're recommending on this call. But if you want to talk more about that, just give us a call and we can absolutely talk about it.
Taylor, as a follow-up to that, we just think it's important to share that some of Excel's rebates do require a qualified contractor to install. So
Yeah.
you might not get those utility rebates if you DIY.
Yeah, thanks, Jess. Good point. They have that requirement for, I think all of the ones we just talked about, they've got that requirement in there. All right, well, it looks like we're out of questions and we're definitely over some time. So thank you all for joining. Thank you to our panelists, Elizabeth, Seth, and my colleagues Narelle and Jess at HC3 for joining. And we will share the recording along with contractor list, rebate list, and maybe some other resources that we can pull together on this stuff with everyone that signed up and the community there. But I really hope that this was helpful and generates some interest in projects, and we can help you guys save energy in those homes in Wellington. And with that, I will wrap it up and stop sharing. Thank you guys.